Okay, here's one example that we'll work together. So this says a paper clip is shot into the air using a rubber band. The position of the paper clip is given by this equation. S is in feet, T is in seconds. So we're assuming, again, only linear motion, so we're moving this paper clip just goes straight up and down. Okay, I want the velocity function and the acceleration. So velocity is just the first derivative. You can label it v of t, which is the same as s prime of t. And acceleration is just the derivative of the velocity function, which in this case is negative 32. Okay. Part B, for how long is the paper clip going up? So when we talk about motion, when is it moving left to right? When is it going up or down? You should always be looking at the velocity function. So I want to know, when is the velocity positive, right? Going up means velocity is positive. So 64 minus 32t, is greater than 0. You can solve that. T is less than 2. And we never talk about negative times, so we're going to assume, unless it says otherwise, that we'll start at time 0. Okay, with what initial velocity does it leave your hand? So initial velocity means what's the velocity when this starts? So the starting is time 0. So I want to know the velocity at time 0. So plug in 0 for t. I get 64. And let's start putting units in our answer, feet per second. Is it traveling up or down at 1.5 seconds? Again, it's asking about motion, so you should always be going to the velocity at 1.5. If I plug in 1.5 into the velocity function, it's 16. And really, I don't care what the value is. I just need to know whether it's a positive or negative number. Because the velocity is positive, I know that this particle is going up. And the last one, is it speeding up? Okay, when you start talking about speeding up or slowing down, that's when you look at the acceleration. So now we're going to plug in 1.5 into the acceleration function. If I plug that in, acceleration is always negative 32, so this is less than 0, so it's slowing down.